Hi everyone, for this question we're being asked to show that n+1 plus n+2 plus and so on up to 2n is equal to n times bracket 3n+1 all divided by 2. So yeah, let's jump in and take a look. So I've written up what we're being asked to show. I think for this question the most natural way to approach it will be to take a look at the left hand side and simplify it to show that it is equal to the right hand side. So if we start with our left hand side, I think the first thing to note is because we're adding, it doesn't really, these brackets are almost a bit of a red herring. They don't really have much meaning. And actually it's probably helpful to, maybe if I use colors, to highlight we've got n plus something and then a plus n and so on, and then all the way up to plus 2n, which is really n plus n, is one way to think about it. So we've got a whole bunch of n's, and then we've got 1 plus 2, and then it will go plus 3 and plus 4 and so on, all the way up to plus our second n, because there's 2 n's here. So actually I think a more helpful way to write out this left-hand side would be n plus and so on to plus n, and we'll have n of those n's, basically, n terms. And then we'll have a plus 1 plus 2 plus and so on up to our other n plus n. And there's also n terms there. Now, for the student who sent me this question, I actually just sent them back this first line of working as a hint to kind of encourage them to see whether, if given this hint, they could then proceed and work out how to finish the proof. And that was really just on the basis that it's almost always going to be the case that if you can work something out yourself, then the learning will be a bit more robust than just letting me work it out for you. I think that there is an argument for what I do, which is essentially guided instruction, kind of you know, showing you how to do something so that you can then go and practice it yourself and you know, develop that knowledge. But where possible, I think if you can work it out without my having to show you first, that's always going to be better. So maybe what I'll do for this video is I'll also put a little break in so that you can press pause, and if you want to, you can have a think whether knowing this first step you could then go and work out the rest. So if that's something you want to do, I'd encourage you to press pause and have a think, and then we'll come back and I'll keep working through this proof. Alright, so for those of you that had a go, hopefully you were able to get there. What I'll do now is I'll carry on. So I think the next step is to deal with these n plus n and so on n times. Now that's effectively n times n, because we're adding up n times. So we can just write that as n squared. That's n times n. And so really now the rest of the question just comes down to what do we do with this bit here. And hopefully if you're getting a question like this, then hopefully you would have learned arithmetic progressions, and effectively this is an arithmetic progression, an AP, with the following details. We've got A, or our first term, equals 1. We've got D, our difference, also equal to 1, because each term we're just adding 1. And then we've got n terms, which we already noted. So hopefully you would have learned that the sum of an AP with n terms, the general formula is n on 2 times 2a plus n minus 1d. So that's essentially what we can do. We can input our a and our d, and we'll then hopefully be able to simplify it to this right hand side. So let's take our n squared and let's add n on 2 times 2 times 1, because we have a of 1, plus n minus 1 times d, which again is 1 for us. So if I simplify that, that's going to be n squared plus n on 2 times 2 plus n minus 1, because it's 2 times 1 is 2, and n minus 1 times 1 is just n minus 1. And then if I simplify that, it'll be n squared plus n on 2. The 2 minus 1 just gives us a 1 plus n. And then if I expand this, we get n squared plus n plus n squared. So n plus n squared on 2. And then the next step would be to get a common denominator, which we know we need because we've got everything over 2. So this will be 2n squared on 2 plus n plus n squared on 2. And that means we've got everything on 2. So we can do 2n squared plus 1n squared is 3n squared plus this n all divided by 2. And then at this point we can factor out an n. So we'll get n bracket 3n plus 1 all divided by 2. And that is the right hand side. That's what we were being asked to show.
Panic boom!
So there you have it. That's how you can tackle that question. I think the essence of this question is, I guess, realizing that these brackets don't really matter too much. And really, we've got two summations going on here. We're adding up n times, and then we're adding up 1 plus 2 plus 3 plus 4 and so on all the way up to plus n. And that is an arithmetic progression. And we can use our rule to simplify that, and then we get there. So for those of you who did have a go, hopefully that's kind of an approach, that approach that I used is similar to what you used. And if it's not, feel free to comment on the video and let me know how you went about it. There's always value in seeing different ways of tackling things mathematically. So yeah, I'd be open to that. But for those of you who did follow along, hopefully the way I tackled it makes sense and it's something you could do yourself if you had to. And yeah, there you have it. Tick boom.